want to take the derivative of p of t equals the square root of t over 4t minus 7. We're going to have to use the quotient rule for this. Before we do that though, I want to rewrite the function so that it has a fractional exponent so that we can use the power rule on it. So remember, whenever you have a square root, that's a 1/2 power. If you have a cube root, that's a 1/3 power, and so on. So once we write the function like this, we can now use the quotient rule. So remember the quotient rule, the way that maybe you can remember it is low d high minus high d low over the low function squared. So low d high, high d low. That's just a memory aid for you if you haven't heard that before. Anyway, for this one, p prime of t, low d high, so that means take the derivative of the low function, 4t, I'm sorry, not the derivative, it means just put the low function, low d high, so take the derivative of the top function now, so that's 1/2 t to the negative 1/2. So low, that's the low function, d high, that's the derivative of the high function, minus high, so that's just the high function left alone, times the derivative of the low function. Well, that function is just a linear function, its derivative is just a constant, 4, and divided by the bottom function squared. So 4t minus 7, whole thing squared. Okay, now simplifying this thing is maybe a bit more challenging than actually just using the quotient rule for the derivative. We're going to rewrite this thing. Since this has a negative exponent, I'm going to write everything back in terms of powers now. So we'll write this as 4t minus 7. Now that 2 is in the denominator of this thing here. So we'll have a 2 down there, and then what else? Since that's a negative, it's going to go to the denominator of this whole thing here, but that 2 is already in the denominator, so this t to the 1/2 will join it. And in fact, let me write that as square root of t. So we'll write this as root t, and then minus, and we'll write this as a root as well, so that's 4 square root t. Okay, and we'll just leave this denominator alone, 4t minus 7. Okay, so now at this point, I mean, if you had written the answer like this into my math lab, I believe it would have taken it. But for the purposes of what we want to do in the future with problems like this, it's definitely not the best thing to leave it in this form. So we would like to get rid of the complex fraction. So complex fraction means that we've got a fraction within another fraction, and we don't usually like to see that. So the best way I found is to get rid of these complex fractions is just to look at what's in the denominator of the inner fraction, the fraction that's within the other fraction. That is a 2 root t. So in order to get rid of that, what we need to do is multiply that whole numerator of the big fraction by whatever's in the denominator here. So I'm going to multiply this by 2 root t. Now we can't just do that in the numerator of this thing. We also have to do it in the denominator. So we'll do that. And then just remember that since we're multiplying this to the whole numerator, we have to distribute that. So that's going to go here and here. Now the whole point of choosing 2 root t is that it will then cancel with what's in the denominator here once we distribute it. Okay, so distribute it here, it cancels with that. That means that all we've got left there in the numerator is 4t minus 7. And then when we distribute that to the second term, the 4 and the 2 will multiply and give us an 8. So I'll have a minus 8. And then the root t times the root t will just give us t. So that's nice. Then the denominator down here, well, there's not really too much we can do with that. We'll just leave it the way it is, except I'll put the 2 root t in front. So we get 2 root t multiplied by 4t minus 7 squared. And then we'll just notice that in the numerator here, we've got some like terms, 4 minus 8. So that's negative 4, so we'll have a negative 4t minus 7, and divide this by 2 root t, 4t minus squared. Now, this is probably the best form to have the answer because, again, what we're going to do with in the future with these types of things is we're going to do something with these derivatives, like maybe set it equal to 0 and solve it or something like that. And it's certainly much easier to do something with this function here if it's written in this form as opposed to this much more complicated form here. Okay, so anyway, this is the answer to that question. MyMathLab will certainly take that as an answer, and I believe if you wanted to, you could even just put it as this, and that would give you the correct answer on MyMathLab. But again, try to practice putting it in this form as well, because we're going to be doing stuff with these derivatives in the future.